Okay, so a geometric series with a ratio of R diverges if the absolute value of R is greater than or equal to 1. Okay. Now, if it's between 0 and 1, might as well rewrite that as a compound inequality. I forgot my less than. Now, if it's between 0 and 1, then the series converges. To the sum from n equals 0 to infinity of a to the power of Rn equals a over 1 minus r. And again, that's if r is between 0 and 1. But not equal to it, just between that. And the proof, I'll actually just load that in with the notes if you're interested, but you don't really need it. Just if you're bored and looking to burn a couple of minutes. Actually, should have made a copy. This one, so I'll know to put it back with my notes. Okay, now the one thing you want to note, because sometimes you'll see it written different ways, that the sum from n equals 0 to infinity of a to the power a times r to the power of n is the exact same as the sum from n equals 1 to infinity of a to the power of r to the n minus 1. Okay, because you plug in 0, you get a to the a times r to the 0 power. Here, if you plug in 1, you get a times r to the 0 power. So it just starts at a different place, but you end up with the same sum. And I'll do the example on the next page so I don't run out of room. All right, so let's say, for example, okay, so find the convergence or divergence of the geometric series sum from n equals 1 to infinity 3 over 2 to the n minus 1 power. Okay, so if we wanted to put this into sum from n equals 1 to infinity times a to the r to the n minus 1 power, we can just make it the sum from n equals 1 to infinity of 1 times 3 over 2 to the n minus 1 power. Okay. So this one will actually be really, really quick, because a is equal to 1, and the absolute value of r is equal to 3 over 2, which is greater than 1. Okay. It The minute we find out it's bigger than 1, we already know it diverges. Okay, so the absolute value of r is greater than 1. So the series diverges. Okay, so what if we have, say for our next example, find the convergence or divergence of the geometric series sum from n equals 0 to infinity of 3 over 2 to the nth power. Straighten that up a little bit. Okay, so you want to put it in the form of a to the power of Rn, well, a times r to the power of n. So what we can do is we can bring that 3 down to the front. Well, actually you can make it to 0 to the n minus 1. Nope, that's 1 to the n minus 1. 0 is just to the Rn. So that was right. Okay, so from n equals 0 to infinity, if we bring that 3 down, we have 3 times 1 over 2 to the nth power. Okay, so remember 1 to the nth power is always going to equal 1 no matter what n is. So you can make that over 1 to the nth power, which means we can just rewrite it from n equals 0 to infinity of 3 times 1/2 to the nth power. Okay, so we know that our a is equal to 3, and our absolute value of r is equal to 1/2, which is less than 1. Okay, so we know it converges. We just have to find the sum now. Okay, so you know that the sum is equal to a over 1 minus r. So I'll put find the sum. Okay, so that's going to equal, our a is 3 over 1 minus 1/2. So that's equal to 3 over 1 minus 1/2 is just 1/2. Multiply both of those by 2, you end up with 6. Okay, so the series converges, and the sum is 6. All right, so sometimes it'll come right in that form that you're looking for, and sometimes you have to kind of manipulate it a little bit. All right, so any questions on this one? All right. That's not bad. All right, anyone still writing? All right. Okay, so let's say we have the example. We want to determine whether the geometric series converges or diverges. And whenever it converges, they always want to know to what. So let's say if we have the sum from n equals 1 to infinity of 8 times negative 3/4 to the n minus 1 power. Okay, so it's already in the format we're looking for. N equals 1 to infinity of a to the rn minus 1. Remember, it can be from 0 to infinity with a power of n, or from 1 to infinity with a power of n minus 1. You'll get the same thing. Okay. So in this case, n equals 1 to infinity of 8 times negative 3/4 to the n minus 1. Our a is equal to 8. And our absolute value of r is equal to the absolute value of negative 3/4, which is just 3/4. Okay, which is less than 1, so we know it converges. Okay, so we know the sum, which find the sum. Our sum is going to equal a over 1 minus r, which equals 8 over 1 minus negative 3/4. Remember, it's not the absolute value of r, it's the actual r. Okay, so that equals 8 over 1 plus 3 over 4, 4 over 4, so that makes that 7 over 4, which is equal to 32 over 7. All right, so any questions on that one? Okay, let's say if we have I'll use this example here, and I'll start a new sheet because that one looks like it'll be a little bit lengthy. Not horribly lengthy, but a little bit lengthy. All right, anyone still writing? Okay. Now, what if we have the example where we wanted to use a geometric series to write 9.17, where that 17 is just repeated over and over again, as a fraction of integers. Okay. So whenever you have a decimal with a repeating portion of the decimal, you know that 9.17 with the bar over it just means that the 17 repeats over and over and over. 17, 17, 17, 17, 17, and it goes on like that forever. Okay, so we can actually get each of those 17s and write them as a sum. So this should just be 9 plus, this is 1700, so that's 17 over 100. This is 17 10,000th, so it's plus 17 over 10,000 plus the next one is 17 millionths, and it just keeps on going from there. Alright, so that's going to equal 9 plus 100. You can write that as 10 squared. So that's 17 over 10 squared. 10,000, you can write that as 10 to the 4th. So it's plus 17 over 10 to the 4th. A million, we can write that as 10 to the 6th power. 17 over 10 to the 6th. All you got to do is look at how many zeros, and that's how you know what your exponent's going to be. And it just keeps on going from there. Okay, so for right now, we're going to ignore the 9 temporarily, because that 9 is not going to change. It's always going to be a 9. And we're just going to focus on this. Okay, so we can actually rewrite this as a sum from n equals 1 to infinity. Oh, actually, let me point out why this would work before we do that. Okay, so this is actually 17 over 10 squared times 1 plus 17 over 10 squared times 1 over 10 squared plus 17 over 10 squared times 1 over 10 to the 4th, and it keeps on going. So that's why we can actually rewrite this as a sum from n equals 1 to infinity. Bring that down a little bit so it's not so cramped. The sum from n equals 1 to infinity of 17 over 10 squared times 1 over 10 squared to the n minus 1. Because here, if we plug in 1, we have 1 over 10 squared to the 0 power, which is our 1. And if we plug in 2, 1 over 10 squared to the first power would just be 1 over 10 squared, and keeps going and going and going. All right, so if we rewrite this, we can actually find out whether or not it converges and what the sum is. So we can figure out the sum of all of those. So if we use the geometric series, which if you remember, sum from n equals 1 to infinity times ar to the n minus 1, and where the sum is equal to a over 1 minus r. Okay, so here, our a is equal to 17 over 10 squared, and our absolute value of r is equal to the absolute value of 1 over 10 squared, which is less than 1, so we know it converges. Okay, now once we know it converges, we just find the sum. Okay, so we know that our sum is equal to a over 1 minus r, which is equal to, oh, let me write that a little lower. I forgot those fractions are going to take up a little more room. Equals a over 1 minus r, which equals 17 over 10 squared divided by 1 minus r, which is 1 over 10 squared. That looks like 102. Let me clear that up. 1 over 10 squared. There we go. Okay, so that just becomes 17 over 100 divided by, we make that 1 over 100, 100 over 100 makes that 99 over 100. So if we divide that, we end up with 17 over 99. Okay, so that's not our answer. That's just the sum of this part. So actually, 9.171717 equals 9 plus 17 over 99. Because remember, we still left our 9 by itself. So that just comes from up there down to there. Okay, so if you just add those two together, you end up with 908 over 99. All right, so any questions on that one? All right. Nope, anyone's still writing. Okay. All right, and actually that is it. I think I'll wait on the next section.